Welcome to this explainer. Today, we're stepping way back in time to explore a world that honestly sounds like it was ripped straight out of a sci-fi monster movie. We're going to separate the pop culture myth from the scientific reality and look at the absolute titans that used to slither across the prehistoric Earth. So if you've got a fascination with ancient giants, well, you are in the exact right place. Let's get right into it. Okay, let's dive into this. Because let's be real, pop culture absolutely loves a good monster fight, right? You see content creators racking up millions of views by imagining these ultimate showdowns, like, I don't know, a T-Rex battling some giant fictional anaconda. And hey, it's a super fun thought experiment. We all love to imagine epic clashes of prehistoric titans. But while those specific matchups are pure Hollywood fantasy, the underlying idea here, the idea of giant predatory snakes sharing a world with dinosaurs and actually outliving them, that is grounded in some seriously mind-blowing hard science. Now, to understand the reality of these giant snakes, we first kind of have to look at our modern obsession with the animals that usually steal the prehistoric spotlight. Whether it's in pop culture through imaginative fiction like Ray Bradbury's classic dinosaur tales, or in rigorous science like Steve Brissatt's fantastic book The Rise and Fall of the Dinosaurs, the narrative is almost always the same. And honestly, rightfully so. I mean, dinosaurs ruled the planet for an astonishing 150 million years. They were the undisputed kings of the Mesozoic era. When we picture prehistoric ecosystems, we picture a world dominated, from top to bottom, by dinosaurs. But I want you to flip the script for a second. Just imagine it. What if, in certain corners of that ancient world, the mighty dinosaurs weren't the ones doing the hunting? What if they were actually on the menu for something, well, a whole lot stealthier? To answer that, we have to travel back exactly 67 million years ago, right near the tail end of the dinosaurs' reign. We're heading to Western India, specifically the Gujarat region, where scientists uncovered fossil evidence proving that for some dinosaurs, this exact nightmare was a reality. Meet Sanajay indicus. This was a primitive snake that measured about 3 meters, so roughly 10 feet long. Now, unlike modern pythons or boa constrictors, Sanajay lacked that evolutionary trick of wide-opening jaws, so it couldn't exactly swallow massive prey whole, but what it could do was hunt 50-centimeter baby titanosaurs right as they hatched. In fact, the fossil evidence here is astonishing. Uncovered by Dr. Dhananjay Mohabay and later identified by Dr. Jeff Wilson, this fossil literally caught the snake in the act. Its body was found coiled in a dinosaur nest, right around a crushed egg and a baby hatchling. Now, adult titanosaurs would eventually grow into these 100-ton long-necked giants, but as babies flailing in the loose sand, they were completely defenseless. Like Dr. Jason Head noted, this hatching season would have been an absolute smorgasbord for these snake predators. It really just proves that the early evolutionary history of snakes was incredibly complex. Let's move along and see how this builds, because just 1 million years after that snake hunted baby dinosaurs, the asteroid hit. 66 million years ago, non-avian dinosaurs were wiped from the face of the Earth, but life always finds a way, doesn't it? We enter the Paleocene epoch, about 58 to 60 million years ago. The dinosaurs are gone, leaving this massive power vacuum right at the top of the food chain. Fast forward our timeline to the year 2009, when scientists made a discovery in South America that would completely redefine what we thought was biologically possible for a snake. Deep in the Cerrejón coal mine of northern Colombia, scientists made a staggering find. Among the rock layers that preserve the Earth's first recorded tropical rainforest, which was this hot, swampy coastal environment connected to the Proto-Caribbean, they unearthed the remains of at least 28 massive snakes. And I'm not just talking about a large snake here. This was an apex predator, perfectly evolved to dominate a sweltering, wet world that was now completely devoid of dinosaurs. And this brilliantly illustrates exactly what they found. When you look at the fossilized backbone from Titanoboa, right next to the equivalent bone from a modern 11-foot boa constrictor, the sheer difference in scale is just wild. This is what cements Titanoboa in hard science, rather than just myth. By mathematically analyzing the shape of these uniquely T-shaped bones, scientists could accurately predict the true massive size of this prehistoric monster. To truly comprehend the scale of Titanoboa, let's contrast it directly with today's heavyweight champion, the modern green anaconda. Now, an anaconda is a massive animal, right? Reaching 15 to 20 feet, weighing maybe 200 to 300 pounds. But Titanoboa, It stretched an unbelievable 40 to 50 feet long. That's about 13 meters, and it weighed over 2,500 pounds. While the modern anaconda hunts in the Amazon, eating birds and tapirs, Titanoboa thrived in those Paleocene swamps, feasting on giant lungfish and ancient crocodile relatives. It is, by far, the largest known non-marine vertebrate from the early Cenozoic era. So how did a 2,500-pound snake actually hunt? Well, while its size was totally unmatched, its behavior did have modern parallels. Analysis of its cranial features revealed that Titanoboa had a really unique skull structure and teeth that were perfectly specialized for catching fish. Scientists actually describe it as having an anaconda-like ecology. Because of its sheer weight, over a ton, it wasn't exactly chasing prey over land. Instead, it was highly aquatic. It used stealth in the murky, warm waters of that Colombian rainforest to ambush giant turtles and crocodiles, utilizing its massive jaws to seize prey before they even knew it hit them. Which brings us to a really fascinating scientific mystery. Think about the basic biology for a second here. Snakes are cold-blooded, they don't generate their own internal body heat. So how on earth did a cold-blooded reptile manage to grow to the size of a literal school bus? To answer this, we have to look at a very specific biological principle. The key to Titanoboa's massive size lies in the concept of poikilothermy. Because snakes are ectotherms, their metabolic rate, and therefore the absolute maximum size their bodies can biologically achieve, is entirely restricted by how hot their surrounding environment is. A cold-blooded animal simply cannot grow to 2,500 pounds in a cool climate. Its metabolism just wouldn't support it. The environment itself must supply the ambient heat required to sustain that massive scale. Now, what's really interesting about this slide is how scientists used that biological rule to look back into the past. By comparing the modern anaconda with Titanoboa, they basically turned this giant snake into a literal prehistoric thermometer. The data here shows the mean annual paleotemperature gradients derived entirely from the body size of Titanoboa. Because we know exactly how big it was and we know the metabolic mathematics of poikilothermic animals, we can calculate exactly how hot the Earth had to be to allow this creature to simply exist. So, the crucial point is this. To support a snake measuring 13 meters long, the mean annual temperature of the Paleocene neotropics had to be a sweltering 30 to 34 degrees Celsius. That is significantly hotter than the modern Amazon rainforest. This data perfectly aligns with climate models of a greenhouse world during the early Paleogene period, which was a time when atmospheric carbon dioxide levels were exceptionally high. So Titanoboa isn't just a cool fossil, it's a living, breathing metric for a radically different global climate. As we wrap up, let's bring the prehistoric past back to our present day. We've seen that ancient snakes hunted dinosaurs, and we've seen that when the Earth's temperature soared, cold-blooded reptiles grew to monstrous school bus proportions. Which leaves us with a pretty profound thought to ponder. In our modern world, as global temperatures continue to steadily climb, altering ecosystems across the entire planet, what new giants might the future hold? Thank you so much for exploring the science of these incredible prehistoric titans with me. Keep learning, keep questioning, and I'll see you in the next explainer.